Welcome to the world of online learning. We at GK Online Learning Tutorial provides its subscribers the topics from software engineering, project management, quality management, strategic management, mathematics and other topics. Today's topic is software requirement engineering. Please like, share and subscribe to our channel for continuous support.
Next topic is processes of requirement engineering in the context of software development models. The processes of requirements engineering in the context of the following software development model like waterfall model, spiral model, prototyping model, operational model, transformational model, the knowledge-based model, and domain analysis model. Lifecycle model. A software lifecycle model, also called as process model, is a descriptive and diagrammatic representation of the software lifecycle. A lifecycle model represents all the activities required to make a software product transit through its lifecycle phases. System development lifecycle, also refers to as application development lifecycle, is a process for planning, creating, testing, and deploying an information system. The system development lifecycle concept applies to a range of hardware and software configurations, as a system can be composed of hardware only, software only, or a combination of both. There are usually 6 stages in this cycle: requirement analysis, design, development and testing, implementation, documentation, and evaluation. A system's development lifecycle is composed of a number of clearly defined and distinct work phases which are used by system engineers and system developers to plan for, design, build, test and deliver information systems. Like anything that is manufactured on an assembly line, an SDLC aims to produce high quality system that meets or exceeds customer expectations based on customer requirements by delivering systems which move through each clearly defined phase within scheduled timeframes and cost estimates. Computer systems are complex and often link multiple traditional systems potentially supplied by different software vendors. To manage this level of complexity, a number of SDLC models or methodologies have been created, such as waterfall, spiral, agile software development, rapid prototype, incremental, and synchronize as well as stabilize. When it comes to project management, a project can be defined both with the project lifecycle or PLC and an SDLC, during which slightly different activities occur. According to Taylor in 2004, the project lifecycle encompasses all the activities of the project, while the system development lifecycle focuses on realizing the project requirements. SDLC is used during the development of an IT project. It describes the different stages involved in the project from the drawing board through the completion of the project. How SDLC works? SDLC works by lowering the cost of software development while simultaneously improving the quality and shortening project production time. Next, it defines the requirements of the new system. It then creates the software through the stages of analysis, planning, design, development, testing, and deployment. It's also important to know that there is a strong focus on the testing phase, as the SDLC is a repetitive methodology. You can to ensure code quality at every cycle. Many organizations tends to spend few efforts on testing, while a stronger focus on testing can save them a lot of rework, time and money. Be smart and write the right type of test. Different lifecycle models. Many lifecycle models have been proposed so far. Each of have some advantages as well as some disadvantages. A few important and commonly used life cycle models are Classical Waterfall Model, Iterative Waterfall Model, Prototyping Model, Evolutionary Model, and Spiral Model. First one, Classic Waterfall Model. The Classic Waterfall Model is intuitively the most obvious ways to develop software. Though the Classical Waterfall Model is elegant and intuitively obvious, it is not a practical model in the sense that it cannot be used in actual software development projects. Thus, this model can be considered to be a theoretical way of developing software. So this is the block diagram of Classical Waterfall Model, starting with feasibility study, requirement analysis, design, coding, testing, and maintenance. Like water is falling through the steps. So Classical Waterfall Model is a basic software development lifecycle model. It is very simple but idealistic. Earlier this model was very popular, but nowadays it is not used. But it is very important because all the other software development lifecycle models are based on the Classical Waterfall Model. It divides the lifecycle into a set of phases. This model considers that one phase can be started only after completion of the previous phase. This is one of the disadvantages we can tell about the Classical Waterfall Model. This is the output of one phase will be the input for the next phase. Thus, the development process can be considered as a sequential flow in the waterfall. Here, the phases do not overlap with each other. The first phase, feasibility study. The main goal of this phase is to determine whether it would be financially and technically feasible to develop the software. The feasibility study involves understanding the problem and then determine the various possible strategies to solve the problem. These different identified solutions are analyzed based on their benefits and drawbacks. The best solution is chosen and all the other phases are carried out as per this solution strategy. Second one, requirement analysis phase. The aim of the requirement analysis and specification phase is to understand the exact requirements of the customer and document them properly. This phase consists of two different activities, that is requirement gathering and analysis as well as requirement specification. First, all the requirements regarding the software are gathered from the customer and then the gathered requirements are analyzed. The goal of the analysis part is to remove incompleteness or unwanted information or incomplete requirement. Requirement specification. These analyzed requirements are documented in a software requirement specification, that is SRS document. The SRS document serves as the contract between development team and customers. Any future dispute between the customers and the developers can be settled by examining the SRS statement. Then comes design phase. The aim of this phase is to transform the requirements specified in the SRS document into a structure that is suitable for implementation in some programming language. Coding and testing. In coding phase, software design is translated into source code using any suitable programming language. Thus, each designed module is coded. The aim of the unit testing phase is to check whether each module is worked properly or not. Integration and system testing. Integration of different modules are undertaken soon after they have been coded and unit tested. Integration of various modules is carried out incrementally over a number of steps. During each integration steps, previously planned modules are added to the partially integrated system and the resultant system is again tested. Finally, after all the modules have been successfully integrated and tested, the full working program is obtained and the system test is carried out. The system test consists three different kinds of testing activities like alpha testing, beta testing, and acceptance testing. Alpha testing means it's a system testing performed by the development team. Beta testing, a test performed by friendly set of customers. And acceptance testing, after the software has been delivered, the customer performed the acceptance testing to determine whether to accept the delivered software or to reject it. Finally, maintenance. It's the most important phase of a software lifecycle. The effort spent on maintenance is the 60% of the total effort spent to develop a full software. There are basically three types of maintenance. Corrective maintenance, it is carried out to correct errors that were not discovered during the product development phase. Second one is perfective maintenance. It is carried out to enhance the functionalities of the system based on the customer's request. And finally, adaptive maintenance. It is usually required for porting the software to work in a new environment, such as work on a new computer platform or with a new operating system. Shortcoming of the classical waterfall model. It is idealistic since it assumes that no development errors is ever committed by the engineers during any one of the life cycle phases. However, in practical development environment, the engineers do commit a large number of errors in almost every phase of the life cycle. The source of the defects can be many, like oversight, wrong assumptions, use of inappropriate technology, communication gap among the project engineers, etc. This defect usually get detected much later in the life cycle. For example, a design defect might be unnoticed till we reach the coding or testing phase. Once the defect is detected, the engineers need to go back to the phase where the defect has been occurred and redo some of the work done during that phase and the subsequent phases to correct the defect and its effect on the later phases. Therefore, in any practical software development work, it is not possible to strictly follow the classical waterfall model.
If you are having any queries, please write to me. Thanks for listening. Please like, share and subscribe to my channel for continuous support. Thank you.